Okay, I've started recording and I'm going to stop sharing my screen in a moment. I think maybe one or two people are still joining us, but I reckon we can get started anyway. So thank you everybody for joining. Today we've got in our breakout session 2 partners. Second will be the second half, Lewis Parks from Veridify Security. But first up we have Jared from Napatech, who's going to talk us through some of their offerings that are leveraging Intel technology. Okay, Jared, you have the floor.
Great, thank you. I'm just going to show my screen here. If you could let me know that it's that it has gone live.
Sure, will do. And in the meantime, if everyone can else remain on mute, that would be great. Yep, can see your screen.
Okay, great. I'll get started. Jeremy, thank you for having us. We're really pleased here to be at the Intel Partner Connect event. Intel's always a great partner to Napatech, and we're pleased to share what it is we're up to in the world of SmartNICs. So today's presentation starts with just a quick background for those that may not be deeply as familiar with this space. Enterprise, government, telco, cloud, and now edge computing networks are going through a lot of changes, perhaps more changes than any other time in recent tech and IT history. And it begins and ends with the cloudification of everything. With all of those mega trends, it's changing the way that people build networks. They're moving away from custom, proprietary, expensive systems into more open and standard computing platforms, servers, and those servers need connectivity. So there's massive growth within the network interface card market, and specifically a segment called SmartNICs. What a SmartNIC does compared to a regular NIC is it bridges the gap between the expectation of the performance of network and cloud-based applications and services and what you can get on a standard server-based system with a standard NIC. Many of these apps and services are very compute and computationally intense, and they're exaggerated when you get to very high packet rates of multi-ports of 25, 40, and 100 gigabits. So what a SmartNIC does and is, it's a high-performance network interface card, but instead of using a standard Ethernet chipset, it's powered by an FPGA. And that FPGA provides extra compute inside of the system to offload the burdensome network and security workloads that otherwise would have to be handled by the CPUs and constrain the system. There are a lot of customer types that are adopting the use of SmartNICs to power their servers. SmartNICs for a long time have been found embedded inside of original equipment manufacturers that build network and security appliances like firewalls and load balancers, and those big boxes that make up your network. In the past several years, there's been an expansion of those markets and a trend where end users are building their own systems by buying software instances of firewalls and load balancers and other security applications and adding those software to servers, standard servers, adding a network interface card and building a high performance system at a much lower cost point. Those type of end users include the hyperscale cloud operators that have invented these technologies, but as well as the tier 2 operators in that space. Significant expansion of the same technologies and architectures in the telco and cable networks, along with enterprises and government networks. And that's part of Napatech's vision. We hope to be the provider of the complete solution of the SmartNIC and the software that powers that SmartNIC for these leading applications in these types of networks. So you might ask yourself, what are these types of applications? And there's no shortage of them. They all share a common profile of being a network a network application or service that resides in the network, is managing the packets and the flows for large numbers of users. And it's not just about moving packets, but they all share an attribute of looking deeply at the traffic for some reason. And it's that combination of high throughput, low latency, and high instructions per packet that create the bottlenecks inside of a CPU when it's using a standard NIC. And stating the obvious, the most valuable and expensive resources inside of your server are the CPUs. So the ability to replace that standard NIC with a highly programmable hardware-based SmartNIC returns all of those valuable resources to the CPUs. But the applications that are very common that use a SmartNIC include cybersecurity. There's a whole host of cybersecurity applications, from firewalls, next-gen firewalls, data loss prevention, intrusion detection and prevention, and many more. Another common application segment that uses SmartNICs are monitoring applications, and these include test and measurement, service assurance, things like application and network performance monitoring. It even includes other categories like lawful intercept and network recording for forensics and analytics. All of these applications, again, share those same attributes of high packet rate to the application and the server that's running it. And the urgency, or the value of the application, is the certainty that it has seen all the traffic and making the right decisions about the security footprint or the forensics or analytics that's going on. Any form of packet loss degrades the quality and the output of those applications. Beyond those, there are applications in infrastructure, network infrastructure, like load balancers and session border controllers, packet brokers, and some of the in the financial markets as well, financial trading, high frequency trading, where every packet and every nanosecond is translated to dollars. Beyond those four traditional segments, some of the highest growth segments looking towards the future are in edge computing and mobile network infrastructure, where those type of networks are mimicking the designs that were germinated in the cloud networks. So there are no shortage of applications and users that can benefit from SmartNICs. In our partnership with Intel, we're very pleased. Intel has a leading and broad set of SmartNIC solutions. Their SmartNICs span every conceivable dimension of price, performance, power, port types, port counts, and densities. And Napatech is pleased to partner delivering our SmartNIC software on these cards to bring the benefits previously stated. One of our solutions is on the Intel PAC card that includes our packet capture software that I'll talk about in just a moment. And then very recently, highlighted here in the big left side of the slide, Intel announced the availability of a new card. This card is obviously, it's targeting cloud and telco and data center operators. It is available from companies like Silicom and Inventec on the hardware side, and Napatech's pleased to partner with all of those companies to make our software available on that card. When you use a SmartNIC, one of the Intel platforms, along with the Napatech SmartNIC software, you get a couple common benefits regardless of your application type. First, it always starts with performance. Performance is paramount. If you have an application with a standard NIC and it meets your needs, there's no need to upgrade to the SmartNIC family. But when you move on to that SmartNIC, performance is typically defined on one or more dimensions of total throughput, packets per second, connections, total connections, connection setup and teardown, and latency. After performance, the second most distinguishing attribute of SmartNICs is the agility that comes from the programmability. We boast of delivering hardware performance, but at the speed of software innovation. We can certainly add lots of features and functions over time for new protocols and new security threats, but each time those are done in software, it further degrades the performance of the system, the server, the application, and the service. By doing those things in programmable hardware, we maintain all of that hardware performance as the life of the card evolves and we continually add things to its footprint. And then the third leg of this stool is the efficiency. By doing all of these burdensome network and security functions down on the NIC where they happen close to the wire where the packets arrive, we're freeing up those resources on the host CPU and returning them to the applications and services and tenants for which they were originally intended. So when you roll those three benefits together across the top, you get a couple things across the bottom. You get a very strong and economic footprint where now you're basing what used to be the most expensive investments in your network now on open and standard platforms, servers, NICs, and the software versions of those applications. So you can get to a very low cost point to allow it to scale to the size of these new networks. Second, when you talk about the scale of these new networks, you just have to build, manage, and operate the networks differently. So these smart NICs bring in a whole new method of operation, management, provisioning, and control at large volume. And then you put all this together, you end up with a really sustainable solution. What you get is the optimal configuration of size, cost, power, cooling, and performance in one package. Napatech is pleased to offer several software packages that are optimized around your specific application. Our first one is called Link Capture. This software product is used specifically for applications that sit out of band or passively. These could include, again, network monitoring, recording in the monitoring space. In the cybersecurity space, there are applications like intrusion detection that sit out of band and data loss prevention. But these type of applications tend to care about 100% packet capture. It really has to be zero packet loss for the app to be effective. Nanosecond timestamping and flow aware. So they've got to be stateful and not just looking at individual packets. This slide shows a brief benchmark that illustrates the effect of packet loss on a leading cybersecurity application. And without digging too deep into the details, what it shows is that even with very marginal packet loss, the alerts that you get out of your system triggering threats and or the ability of the application to dig inside of the payloads like files and other content to look for malware and other bad actions plummet through the floor. So it just reinforces that the value of a smart NIC with its ability to provide guaranteed 100% packet capture and lossless delivery shines through. The second method or software package that is available for the smart NICs is what we call our inline software. And this is specifically optimized for applications that are active and deployed inside of the network, not out of band, that are moving traffic east to west. In these type of network applications that tend to be apps and services and appliances, you have a different set of focus areas. In this case, a really high throughput through the system. The card's got to be able to do 200 gigabits, 100 gigabits bidirectional in each direction across multiple ports. And when you get to those higher capacity links within the network, you're going to be very concerned with the scale of the number of simultaneous users, sessions, and flows, and how many you can set up and tear down at any given time. So the software is optimized for that use case. For this application and use case, I have a nice benchmark that I like to show, a case study from a leading tier 1 cloud-based social media company who had a cybersecurity requirement for 180 locations for a 40 gigabit security mechanism. And a commercial system and a hardened appliance at about that size would cost you $225,000. So you can do the math and see how expensive this gets. They went down the journey of applying a software version of that security application on a standard server with a standard NIC. And obviously they were able to dramatically lower the cost, but it never got to the performance requirement needed for the application. So the next third step was to cluster a number of those servers together, add an external load balancer, build a management interface that sat over the top of it. And it got to the performance. It still had saved some costs, but it was clunky and unattractive. And where the final decision landed was a standard server powered by a smart NIC in a single instance. It was able to meet the performance requirements and at the same time dramatically lower the cost. And then obviously extrapolated over 180 nodes. It certainly paid for itself at the outset. Our third package is what we call our Link Virtualization software. And this is software that's used in cloud, telco, and enterprise networks where virtualization is being deployed. Those familiar with it will know it as a classic OVS offload and acceleration. And the value here is, again, the high performance that we deliver through this system, but most importantly, the fact that that virtual switching engine is no longer burning a majority of the cores that are available on the host side. That function is pulled down to the smart NIC to deliver both the performance and the offload. And similar to the other slides, I just have a simple benchmark here that shows the performance of a smart NIC in a virtualized network and server deployment versus a standard NIC, as well as some other competitive offerings in this programmable smart NIC space. And finally, the green bar there that represents Napatech. So the combination of the Napatech SmartNIC software and the Intel programmable SmartNIC hardware delivers the highest performance within the industry. Finally, just a comment on Napatech. For those of you that may not be familiar with us, we're a public company. We're listed on the Oslo Stock Exchange, and we're headquartered out of Copenhagen, Denmark. We've got a long history entirely focused on building FPGA-based SmartNIC solutions, and with a heavy emphasis on our software to power them wherever they show up in server platforms. Our business today is a mix of OEM customers who use our solutions and embed it in their appliances, as well as end users across a wide segment who are building their own systems. You can find our products direct from us, as well as in partnership with key systems integrators, servers, and semiconductor companies. And so I want to thank you all for your time today and listening in, and I look forward to connecting with you after the presentations today if you have any questions. Thank you.
Thanks a lot, Jared. So as Jared said, he will be available for any questions afterwards as well. You can chat with him via the FPGA Accelerator booth. So are there any questions at the moment? I haven't seen any messages in the chat box, but are there any questions before we move over to Lewis Parks? Okay, Lewis, you can start sharing your screen if you want. Lewis Parks is from the CEO and chairman from Veridify Securities. And over to you.
Great. Thank you. Thank you, Jeremy. Thank you, Jared. Great presentation. And I guess good morning and good afternoon to everybody. So I'm with Veridify, and we're here today to talk about Dome, which is our device management SaaS platform for securing devices, industrial IoT, smart cities, and smart buildings. And just two quick slides for some of you who may not be familiar with Veridify. What I have here is sort of a very simplistic topology of what many of us would be familiar with in the outside world. And again, on the right-hand side, very familiar with securing many applications and platforms that run on gateway hubs and more powerful processors up to the user, whether it's over a network or a cloud. Veridify is focused on the left-hand side of this diagram, which is the small devices that connect at the edge, that might be sensors, actuators, again, in the IoT world, that also need to be secured. And when we say security, what we're referring to is authentication. Is that my device? Is this my owner or hub? And then protecting the data that moves between it. So in essence, complementary to some of the security, cybersecurity that Jared mentioned in their products, which is monitoring platforms with their NICs and identifying intrusions. Our technology and our goal is to prevent those things from happening. So a very simple introduction for Veridify and what we do. And again, just as one more slide on us, we've been involved in a variety of complementary areas throughout the industry, recognized by some of our partners, and of course, certified in this particular case, ISO 26262, for those of you familiar with the automotive market, safety certified with our tools, and PSA certified in this particular case for the Dome client, which we'll talk about in a few minutes. So that's who we are as a company, and an Intel partner for many years, showing here a solution that is part of our Dome platform on display at Intel's Center of Excellence in China. So just getting to the solutions that I wanted to talk about today, we really solve two problems when it comes to security in the IoT. One is device to device. Many of the platforms you'll be working with, and in particular FPGAs, will come with very good tools to protect firmware and software that you have on it, ensure that the firmware or software that you use is in fact correct. We find that the challenges come when that hub or gateway is now going to talk to an edge device, and you need to authenticate, much like we do on a browser when we're doing our banking or purchasing. But of course, now at the edge of the industrial IoT in a building, you don't necessarily have a person there to negotiate that handshake. So we've developed tools that will fit on very small 8, 16, or low resource 32-bit processors and talk to your hubs and gateways, perhaps powered by an Intel FPGA, or in some cases, even low resource Intel FPGAs like the Max 10 at the edge. We support both legacy tools as well as our own quantum resistant tools, so we're crypto agile. And the second thing which I want to focus on for today's talk is Dome, which is our SaaS IoT device management platform. We recognize there are a lot of device management platforms out there, and typically they start with the device powers up, it has a URL, and it calls home. That's great, but we recognized, again, going to the low resource devices that we typically operate with, that the device may not, in fact, connect to the cloud ever, only to its owner, and the owner, in turn, may connect to the cloud. So how do you address that? So we've developed a solution that allows you to onboard those devices easily and quickly. We have built in, as part of our cloud component, a blockchain credentialing capability to ensure that you're only working with authentic parts that you may be using, or enabling, again, an Intel FPGA to authenticate any edge device that it's either collecting data from or sending commands to. So I'm going to talk a few minutes more about Dome in this presentation. So let's look at some of its use case and applications for today. In addition to industrial IoT, we see smart cities. So our focus, again, is on the actual authentication and identification of devices in the IoT, and then protecting the data moving between those devices. Again, complementing many of the solutions out there that are monitoring networks, measuring and identifying intrusions and anomalies on a network in the world of cybersecurity. We recognize that there's a significant cost when you're deploying a large number of devices. So we've created tools that allow scripting and zero-touch onboarding of those devices when they power up, challenging the network and or owner to prove who is the rightful management owner, and managing the entire lifetime of each device in the platform in a blockchain. So this allows us to scale to significant volumes. And of course, as I mentioned in the introduction to the tools that we use, our tools are quantum resistant to all known current attacks, and we do support legacy methods for certification purposes and other needs. So the platform is crypto agile, and will also support various tools in the future. So all key components to arguably rolling out a scalable model, for example, to a smart city. But I'd like to drill down now on a use case to wrap up, looking at the building marketplace as an example. So although today we often refer to buildings as smart buildings, in fact, buildings for years, arguably even decades, have had processors in them managing the HVAC systems, lighting, access controls, elevators, fire control systems, etc. Today, for convenience, we're seeing those OT or operational technologies being connected to the IT systems, because many building owners want to take advantage of accessing their management system or control systems through the internet, through the IT side. Look on an iPad, see what my power consumption is. By that connection, it's creating exposures and threats to the building. And so if a bad actor can gain access to the system, they can do things to the building, or inverted, use the building as a tool to gain access to the IT network. So this actually creates a significant issue because it creates a threat to the occupants of the building, and it may in fact create both a reputational and financial risk to the owner. And I want to point out that this is not something that we're planning to have to deal with in the future. This is something that's happening today. There are reports ongoing basis. One of my favorites is on the upper right-hand corner, where hackers used the connected OT elements of a fish tank cleaning apparatus in the lobby of a casino to access the IT system, go to the back office, and steal the data on high net worth individuals. And there are many other famous hacks of a similar nature. So this is something that we see that needs to be addressed today. How do you protect the interconnectivity between OT and IT? In the building use case, what we're looking to do is create a cyber safe space. In other words, make the building fully cyber safe. As you can see on the left-hand side, we expect to find controls for access, HVAC, lighting, fire, sensors in parking lots and in rooms, all the various things that are being added to buildings today to make them better, smart, and more efficient. In this particular case, we're using a security gateway that enables us to connect to those controllers via TLS or another secure platform to create a secure connection. And out the right-hand side, put in what we call S-Link, our secure tunnel over the building automation protocols that may be in place to connect to the edge devices. I want to mention quickly that Dome does not replace anything you may currently have in place today. It complements it, much like the way a VPN complements your existing network or platform. And again, at the very edge on the right-hand side, we have tools that can be embedded directly in a device. So for example, in the case here of these room monitors or temperatures, they can have a Dome client embedded in them. We are set up to manage coming protocols. And we also have a very compelling technology developed in conjunction with Intel and supported by their FPGAs, in this case, the Max 10, called the bump in the wire. You may have a pre-existing infrastructure, as many buildings are, including industrial IoT, but you need to add security. The challenges and the hacks today were not contemplated 5 or 10 years ago when you put the system in. So you can actually retrofit Dome to a pre-existing system by using these bump in the wire devices. Very simply, they have all the security client components on them needed to protect the network right up into that point. On the right-hand side, in this particular case, again, you may have a building device, a thermostat or what have you installed, and it will operate oblivious to the fact that right beside it is a bump in the wire, and everything going from that point up to the security gateway is now running over a secure tunnel and encrypted. So a lot of different features and functionalities to complement not only pre-existing, but again, with the availability of our solutions all in software, we can be implemented directly in products you may be shipping today. So no need for the bump in the wire. So in summary, the Dome solution that we've developed is software-based. So we find that it very, very nicely complements Intel's FPGA world and how you leverage as you need the various platforms and capabilities of Intel's FPGAs, whether it's at a hub or gateway or at an edge computing device. The zero-touch onboarding allows you to scale the addition of these very sophisticated products that are doing a lot of computing at the edge today. The in-field owner management and the credentialing via blockchain ensures that your supply chain is not only secure, but the devices you're putting on your system and network are in fact the ones that you ship to your customers. And the mutual authentication, once a device boots up and ensures that it's talking to the owner and the owner knows it's talking to a device, allows the delivery of additional features like over-the-air or over-the-network firmware updates, in-field provisioning, and other types of solutions. And by the way, you do not always want to be connected to the cloud. So many solutions that say, great, dial home, connect to the cloud, and now you're ready to run. We know that many buildings, and in particular, many federal buildings, do not want to be connected to the cloud because that, in fact, creates the tunnel or avenue for the hacker. Our system is designed to work totally encased within the building and only connect to the cloud when it needs to either get new credentials or provide data from the operational elements. Again, we're crypto agile, so long-term solutions, again, buildings get installed with equipment for decades, need to be thinking about quantum resistance. And there are laws coming out today, particularly in the US, about cybersecurity, in particular, a recent federal guideline for cybersecurity 2020 that the federal government's meant to be following, and Dome enables the compliance to that particular law. Again, everything we've talked about today is available in software and software libraries, so they can be applied to your solution. And in fact, the Dome client, which is a very edge component, runs roughly 15 to 24K of ROM at the edge device. So it will probably fit in most of the devices you have there now. And in fact, has been PSA certified level 1 at this point. So that is Dome and the Dome solution. We're happy to be here today. And Jeremy, you can take the floor. And I don't know if there are any questions.
Thanks, Lewis. So let's just ask first of all, does anyone out there have any questions for Lewis? I believe Jared's still on the line as well, so we can actually possibly catch him if there's any questions. Okay, then if not, you are welcome to move back over to the FPGA Accelerator booth, where you can also find Jared and Lewis as well if you want to reach out to them and see their credentials. All right, so on that note, thanks a lot, everybody.
Thank you all. Thank you, Jeremy.
Thank you.
Thank you,
Well done.
Lewis.
All right, pleasure. Take care, everybody. Bye-bye.